Great. Hope everyone's enjoying reInvent. I have my replay party t-shirt on, so I'm getting excited with all the sessions and hopefully a fun party later today. If you're in this session, it's IOT401, Implementing Multi-Region AWS IoT. My name is Olawale Oladihin. I'm a Senior Solution Architect Specialist for IoT. We have the pleasure of having Lucas Sterrett from Analog Devices, a Cloud Solutions Architect. So we have a lot to cover in this session today. We tried to pair as much as we can, as much content we can in the next 60 minutes. But it's going to boil down to three things. The first thing is really why should you do multi-region for AWS IoT? Why do you think about doing multi-region for your devices? And then the considerations about that. Then we'll get into the foundations of going multi-region. There's certain things you have to do up front before you start deploying your devices across multiple regions in AWS. So we'll talk about those best practices next. Then we'll have the pleasure of having Analog Devices talk about their multi-region journey. And then we're going to get into a bunch of architectures for the different types of multi-region deployments. So why do multi-region in the first place? So I get the pleasure of working with a lot of IoT customers, and they basically say, well, with AWS IoT, I've got to do multi-region for a number of reasons. Primary one is latency. Right? I don't want to ship a product over to Asia and then have it go connect to US East. That's just inefficient for us. It makes the whole interaction of IoT just too slow. You also say just for resiliency. Like, well, as Werner talked in his keynote, you might have these individual cells or AZs or regions, but we want to be resilient across regions. So we need to be able to cut over from one region to another. And there are also customers who just want to do it for disaster recovery. So you really want to just have a backup of all of their devices, all of their device state, all of their certificates, and then be able to pre-populate them or repopulate them into a target region. So we know the why, but what really makes IoT and multi-region unique? If we think about the kind of traditional web applications, our users come to our site, they're using their laptops. If something goes bump in the night on our website, we can simply display a message to the user, and then we get this user-driven interaction. They can decide when they want to come back and retry, essentially, your site again. When you get devices in play, it's actually very different. Of course, we all know devices are constrained, but what that also means is that all of your retry logic, all of your redundancy, resiliency has to be planned up front. If your firmware basically gets to a point where it says, well, I'm starting to run out of memory, I don't know what else to do, now you have a memory leak problem. If it keeps backing off and retrying, it has to say, well, at what point do I start getting rid of metadata or state that I have stored locally so I can make more room and continue to process? So this makes it much more complex when you're trying to do these multi-region deployments because you have these constrained devices and you need to do a lot more planning up front. So when it comes to multi-region, there's like several different layers, and these are kind of like IoT layers that we delineate when we talk with customers. Everything from the edge, which is like SDKs or Greengrass or Amazon FreeRTOS, to provisioning, which is your security and identity, communication with AWS IoT Core, the pub-sub protocol, ingestion, where does that data go next, and then applications analytics, where people actually put the business value, so to speak, into their IoT applications. For this talk, we're going to focus on the first four. The reason why the ones in green we're going to focus on, the edge, provisioning, communication, and ingestion, is that these are actually unique to IoT applications. Once you start getting into applications and analytics layers, those are kind of tried and true multi-region approaches. Do I take RDS, and do I take RDS and put it in another region? Do I take my analytics and my big data and get it from S3 in one region to another? It's kind of independent of IoT, but these first four layers are very unique to it. So we're going to spend a lot of time on those. Since we are in Vegas, we're going to transition to figure out what really table stakes is. And if you're unfamiliar with table stakes, or you haven't gone to any of the tables yet, you go sit down, you play blackjack, you play poker, and you've got to put a certain amount of money down in order to sit down and play the game. Similarly, with going with IoT, there's 4 table stakes that you have to do up front before you can think about going multi-region. These are your table stakes. If you don't do them, then it's going to be much more difficult once you go multi-region to add them in. Those are your account structures and your region structures. How do you pair accounts to regions? And how do you then decide how to replicate between those accounts and regions? How do you actually bootstrap your device? If you're unfamiliar with bootstrapping, it's vital to have some process to give your device configuration information on the fly. And that's what bootstrapping gets you. You have to be able to do over-the-air updates. Of course, there are customers who say, yes, I can do this, but you have to go send a field technician out to go do this on a tractor manually. It's not super scalable. So you have to be able to do this over the air. And before you're thinking about multi-region redundancy, you need to think about single region redundancy and resiliency. So we'll give you some best practices about how that looks in a few slides. So let's dive into each one of these table stakes in a bit more detail. So the first one is, how many accounts and how many regions should I have in my AWS IoT deployment? So most customers start here. They have one account for all of their regions. Just to get a show of hands, how many of you are running AWS IoT today in dev, test, production? How many of you have something similar? Whatever AWS IoT you run in, it's one account and it runs in any of those regions. This is pretty standard. Most customers start here. You have one account, that's your production account, and anything in production lives in that one account. When we start thinking about multi-region AWS IoT, it gives you some pros. The replication is easier when you have one account and all your regions are using that single account. But when you start to figure out where do you replicate this data to, so in this example, I have US East 1 and US East 2. Well, okay, maybe they're paired, but what about the EMEA regions? Do I pair them with the US regions? Which one is my failover and which one has a replica of my data? You kind of have to implicitly map this when you do one account for all of your regions. So what should you be looking at if you're planning to go multi-region? We actually recommend you should start segmenting, isolating your accounts. You can do that in two variations. The first one that we actually recommend for customers to do for multi-region is to have one account per deployment. And think about a deployment as a group of your regions that are used for replicating of a specific piece of data. A good example in this case is Americas. If I have American devices or devices deployed in the Northeast or North America, I basically will say I'm going to use US East 1 and US East 2, and this is my one account. If I'm going to do something in Europe, I'm going to create a brand new account, and I'm going to have EU Central 1 and all of my EU regions there. What this allows you to do is that with this one account per deployment, you get this easy mapping between which accounts are your backup and which accounts are your primary. And you also then get a slightly reduced blast radius in a sense that if something were to happen within this isolated deployment, it doesn't impact your other geolocations. You can also take this one step further. So if you are just in the business of saying, I want disaster recovery, the only thing I want to do is if something happens inside of my AWS IoT account, I have a copy of all that data completely isolated that I can go and pull from and essentially restore into my primary. In those cases, you still want to shoot for isolation, but you can go a little bit further. You can do one account per region. Again, we're limiting the blast radius, right? I care about disaster recovery. If someone comes in and deletes all of my certificates, I need to have something they can't go reach out to as well. So I give each account a single region. So that's the first table stake, all about your region and account deployment. The next one is, can you programmatically give your devices security and identity? This relates to bootstrapping. So if you're familiar with bootstrapping, you basically give a global endpoint. This is where your device goes and connects to say, hey, I'm trying to figure out where I should go. That endpoint returns device configuration information. That should be in AWS IoT, your MQTT endpoint. So right now, I'm not hard coding a regional endpoint into my firmware. I'm just hard coding this bootstrapping and saying, go find which AWS IoT region to connect with. You put things in there like retry logic, your health checks, information that's configurable on the device that you want to be able to change on the fly on a periodic basis. And an important part of bootstrapping and device configuration is to make sure you're using your own certificate authority. It's really, really nice because AWS IoT lets you use our certificates. We'll provision them for you and give you a private key and a cert. But if you really want to do multi-region, you have to be using your own CA. So to give you an idea of the bootstrapping architecture, it's pretty straightforward. We've got a Route 53 implementation. We use the private key to essentially sign private information to prove that we own the private key, and we send that along to Route 53. Our backend infrastructure, API gateway and Lambda in this case, will basically look at that device information and return configuration back to the device, including which MQTT endpoint to connect with. Our device happily goes along to AWS IoT and then connects there and starts publishing and subscribing. To give you an idea of what these kind of responses will look like, your response will basically have kind of two main portions. One is kind of the endpoint information, like where am I supposed to go? And the other part is the topic information. What can I publish and or subscribe to? If you look at the endpoint information, we include essentially an object of each endpoint that's available for this device. So right now I have US East 1, but I can list any single endpoint that device can connect to. I also list the CAs, and these are actually the server-side CAs, not the device-side CAs or your certificate authority that sign the device certificates. These CAs are to be able to let you know that if I go connect to this endpoint and I do mutual TLS, which server certificate do I need to present to you? And this is why we include this inside of the endpoint information. Then we can include other things like whether you're primary endpoint or your backup, or how often do you retry on this endpoint before you go somewhere else. Similarly, with the ability to bootstrap, you can send additional configuration information. And the reason why topics are interesting to send when we get into multi-region later is this allows you to define what your rules do later on. You can then define rules that say, well, my configurations look like this. So whenever I see a rule come in AWS IoT, I can look for things to start with command and config, and then send them to a specific location. So I mentioned before, to do bootstrapping, you really need to use your own CA. To give you an idea why, I mentioned before, if you get certificates generated by us, they stay in that region. So you ever go into the console and you do a quick start, you issue a CSR, you say, give me a cert, it's going to live in that region you gave it to in perpetuity. So the only way you can do multi-region if you're getting certificates from us is that when you go to a new endpoint, you have to go get brand new certificates. And of course, we're on constrained devices. We don't really want to be managing 2, 3, 4 certificates. If you use your own certificates, customer-generated certificates by your own CA, those are multi-region by default. And then you can use any of these 4 mechanisms in AWS IoT Core, whether that's bring your own certificate, just-in-time provisioning, bulk provisioning, just-in-time registration. Any of those will allow you to register in a region and then also register that certificate in other regions. So the next table state was really building single region resiliency. And these really come into a few things. If you're not using AWS IoT Rules Engine error action, just a nice way that if for some reason we can't write to the downstream service, we can then pick another service to write to on your behalf. So if for some reason we can't get to Dynamo, you can say, send this data to Kinesis, send it into S3. And with this single region resiliency, you can still continue to operate even if other service downstream is impacted. Also, make sure you're writing to multiple upstream services at the same time. Many customers will say, well, I just put everything in Dynamo. It's like, well, what do you do for archival? Do you put that in Dynamo too? Instead, think about, okay, I'll have some data in Dynamo, but I'll put all my archival in S3. If I miss some data in Dynamo, I at least still have a copy of it in S3. So again, just creating more resiliency and redundancy in a single region. Use services that use multiple AZs. Just makes your life a little bit easier. I'm going to hopefully squeeze in a demo later, but all of them use services that are already running across AZs to give myself additional resiliency. And also have retry logic, not just on the cloud side, but also on your devices. Again, you have to pre-program in all the things the device has to do. To give a quick example of how you can think about this retry and configuration logic with bootstrapping, so right here, I have, if you look at that first arrow, it's basically just a way that I can pass in configuration information to the device. So I'm basically saying, I'm going to send you some information on the fly related to how often you retry. And then at the very bottom, I basically have inputted my retry logic. And they're kind of common things, like how many retry attempts do I have? How many seconds should I wait? Even things like skewing. What is my kind of skew or exponential backoff I should actually use? And by being able to set these from the cloud down to the device, you're also able to essentially give the device new information when your cloud side is impacted. So let's say you're experiencing longer latencies. You can tell the device, oh, by the way, actually, can you back off a little bit more because I have some latency issues and I'm not able to process as quickly as I normally can. And the last table stake is being able to do OTAs. And again, this is important because even if you have this single region resiliency with all your upstream services, when they're connected to AWS IoT Core, you might be sending data in, and everything's working fine. For some reason, one service starts to be impacted, but again, you've got single region resiliency, you're doing great. Then you start realizing other things start to be impacted, and you're like, holy crap, like I really need to move these devices. Since in this example, AWS IoT Core isn't impacted, you can essentially issue an OTA update just like you would the bootstrapping API. You're saying everything's working with AWS IoT Core, but for some reason we're having internal issues. I need you to go somewhere else. And again, the ability to do OTA updates really give you that mechanism of proactively changing state on the fly. So just to recap these table stakes, these are the things you have to do before you go multi-region. Figure out your account structure. Again, one account per deployment, grouping those deployments for what you're going to deploy to, your primary, your secondary, your active-active, both your primaries. You have to be able to bootstrap your devices. This is over HTTP, but being able to make that call just allows you to just get additional metadata back. OTA updates, and also single region resiliency. With that, I'd like to bring up Lucas Sterrett, because he's going to talk about how they took some of these practices and started implementing this for their multi-region application.
Hey, everyone. I hope that, that your reInvent has been a blast so far, and I hope that when we all go home tomorrow, we're leaving inspired and kind of excited to take these things home and build new great things with them. I'm Lucas Sterrett. I'm a cloud solutions architect at Analog Devices, and I'm excited to be here today to talk to you a little bit about one of our industrial IoT applications that we've been taking multi-region. But before I get into that, a little bit about who we are at Analog Devices. If you've heard of us, you probably know us as primarily a semiconductor company, and we specialize in data conversion and signal processing technology. We've been in business for 53 years, and we've grown a pretty cutting-edge portfolio over that time of analog and mixed signal technologies. And also through collaborating with our partners and customers, we've built a really deep domain expertise in domains such as industrial Internet of Things, renewable energy, and healthcare. And we've been using this expertise in signal processing, data conversion, all these things, to bridge the physical and digital world. So essentially, any time that physics of the real world kind of interfaces with digital, you'll find Analog Devices and you'll find our technology. And we've also been extending these expertises in these technologies to the cloud via AWS IoT and other AWS services to build full end-to-end solutions for our customers and our partners that deliver trusted insights, to improve the outcomes in our customers and our partners' businesses. A formidable challenge in all this, and kind of why we're here today talking, is designing our IoT applications so that they're multi-region ready. We want to deploy these things to customers that are all over the world in all of these different geographic regions. And to do that, we have to design our applications in such a way that they can be deployed across regions. So I want to talk about a little bit of that today. The product that I want to talk about is our Argus M machine health monitoring product. And what this is it's a solution. It's a bunch of ADI sensors and connected with AWS IoT, designed to provide kind of an end-to-end machine health solution for our customers that are running heavy industrial machinery. And so if you look at this kind of architecture overview, starting from the left, we're building from edge nodes. So we have these edge nodes. They're equipped with ADI sensors, and they're installed on heavy industrial machinery. And they're designed to operate on battery power. They're very low power. They're designed to operate on batteries for multiple years without needing to recharge the battery or replace any batteries. And then the edge nodes are locally mesh networked together with the technology, our ADI Smart Mesh technology, which is a local mesh networking technology that is specifically designed for these very low power devices, industrial grade. And then data that's collected from these edge nodes is then sent through a gateway device via AWS IoT up to our cloud analytics engine. And then, of course, at the far end of this, we have an intuitive user interface that allows our customers to see live status via a dashboard. We have some device management features. And then also, that's the way that we deliver kind of the relevant machine health alerts and outcomes. And here we have a picture of one of our Argus M deployments. This is actually deployed at our own fabrication facility in Wilmington. And in this picture, we have 15 edge nodes monitoring 13 assets, with those assets being these large water pump motors. And you can see the edge nodes. They're installed over the bearing races on the back end of each of these pump motors, and they're collecting detailed vibration data. In a normal operation, this vibration data that's collected is sent, and summary data of the device is sent every 6 hours, and then with detailed vibration, complete raw data sent once daily. And so a couple things to note about this picture that sort of drives our multi-region requirements for this particular application. For one thing, Argus M has a little bit of a natural tolerance, as you might expect, to downtime of the AWS IoT core service. And the reason for that is because of kind of the natural sparseness of data transmission. So, for this particular application, we're not working with real-time data. We're working with, we collect vibration data over long periods of time, send it up sparsely. And so if AWS IoT core is down temporarily, we can queue that data on the gateway, and then we can send it up for analytics later. And so for this particular application, the uptime of the services may not be our highest our highest priority requirement. Another thing to note is that this picture, it looks really pretty. This environment, it looks like you could easily walk through there. It almost looks like Christmas, as we amazingly rush toward that holiday already. But most of these, and at least many of these heavy industrial environments are often very, very harsh. And so physically interacting with these devices after installation can be difficult. It can be impossible, which is why these devices are designed to work on battery power for multiple years. And so one of our key requirements going multi-region and for this entire application is to minimize physical interaction with these installations, because after they're installed, sometimes it can be even impossible to get to them later. So over-the-air updates, being able to dynamically update configuration, these things are very important to us. So now that you kind of have a sense for that, let's talk about some of our multi-region requirements. First of all, we have to be able to operate devices in multiple AWS regions that are best suited to the customer or the installation geolocation. And we do this for a few reasons. As Wally mentioned, minimizing latency and chance of connection failure, those are very important. Even though we're not dealing with real-time data, the closer we can have our cloud application to the physical installation, the lower our latency and the less chance we have of connection failure with those devices. We also, and as a lot of you guys are probably thinking about also, in many cases there are regional data handling laws that vary geographic region to geographic region. And so being able to operate in multiple regions allows us to properly comply with the regional data laws where applicable. The other thing that we need is we need to be able to operate the devices in multiple AWS regions without re-provisioning the keys and certificates. And this is really important for being quickly agile with these devices and flexible. But first of all, we want the device, the device's key and certificate, that's the device's identity. And we want that identity, because the device doesn't change when it's moving between regions, we want that identity to be stable while the device is moving between regions. Not only is it difficult and fussy to change keys and certificates and to reissue, but it also means that you're sort of changing the identity of your device as it's known cryptographically to the cloud. And that's something we don't want to do. We want that identity to be trusted and to be stable and consistent for that device across regions. And then, as I had mentioned previously, we must be able to migrate devices and dispatch OTA updates, update configuration for these devices, and do all of this without physically interacting with the devices, because by the nature of this Argus M product and the installations in these heavy industrial environments, often it's far too harsh of an environment, expensive, difficult, or even impossible to access these devices after installation. So those are some of our requirements. And now I want to talk to you about one of the kind of fundamental implementation patterns that's really helped us achieve some of these requirements and be particularly agile when we're moving devices between regions and being multi-region ready with our application. And we call this the registration and claiming pattern. And so the idea behind it is that we are separating the connection to AWS IoT Core from the device and its provisioning with the activation and association with an application into two distinct steps. So we're making these things separate. Rather than baking full application and customer association configuration into the device right from the beginning, we're essentially separating the task into provisioning the device and connecting it to IoT Core in whatever or multiple regions that it's going to operate. And then in claiming, that's a separate task after the device is already registered, whereby we associate that device with an application and it's ready for business use in our application. So again, connection and then claiming is associating with an application. Two separate steps. And so let's dig into that a little bit. Device registration, what are we doing here? So first of all, it's the beginning of the life cycle of the device. We're provisioning the device with a certificate and with an initial MQTT broker endpoint for the region in which that device will first operate. And so we're taking advantage of just-in-time registration, which is a really great pattern that Wally had mentioned that AWS IoT offers for certs that are issued by a certificate authority that you own and that you register with your various accounts in the various regions for your deployment. And so because we have our CA registered in any region this device operates, we can just-in-time register it upon first connection. All it need do is connect. And upon connection, we have a rule listening for the just-in-time registration event. And what it will do is it will create a thing in the IoT thing registry. And then it will also, and this is important, it will connect a restricted policy to that certificate so that the device can maintain its connection to IoT Core, but it's not ready for business use. Again, it's not associated with its application and owner just yet. So it's in a restricted state. It's able to connect and interact with its shadow, but it can't publish to any other MQTT topic, which is going to be the full use of the application later. And I wanted to take a quick aside to talk a little bit about a great way, kind of an implementation trick that I really like that makes just-in-time registration even better and kind of supports some of that dynamic decision-making that Wally was talking about when he was talking about bootstrapping. So I have here a snippet of one of our device certificates. And I particularly want to focus on the common name field. So if you're familiar with X509 certs, you're aware of the common name field. But look at what we do here. We found that the common name field is a really great place to put lifetime, persistent, locked, identifying characteristics of the device and bake them right into the certificate, which is the cryptographic identity of the device. And you can also see that we format this as a JSON string, which just makes it really nice. Upon this just-in-time registration event, you can have a Lambda or one of your other functions that can easily parse this stuff out and make smart and tailored decisions for what we're going to do with this particular device based on some of its identifying attributes that are persistent and lifetime locked to the device. And so you can see in this particular example, we have a globally unique ID for this device. And upon registration on that first connection event, this will become the thing name in the thing registry. And then we can have other identifying attributes that we also put in this string that maybe help us tailor our decision upon registration. So I think this is a really great trick if you're using just-in-time registration to take advantage of that common name field and do some smart things with it. OK, so we talked about registration. Claiming. Claiming is kind of the second half of all of this. So the device, because it's been just-in-time registered, it's already represented in the thing registry, and it has its restricted policy attached. But then that registered thing is associated with an owner and application through an API call from an authenticated user, and this comes from the end UI, and that will reference the device's unique ID. And so the Lambda that handles that claim API will then, upon the claim call, it will update the device attributes to associate it with the proper owner and application, and it will replace that restricted policy on that device's certificate with a policy that allows the device now to start full business operation in our application in the region that it was claimed here. OK, so how do these two patterns kind of give us particular agility when we're trying to take our application multi-region? It does it in a handful of ways. First of all, registering in multiple regions, because we're taking advantage of just-in-time registration and because our CA is registered in any of the regions in which we're operating, we don't need to re-roll certs and keys for the devices. And Wally mentioned this, that this is important to use your own CA, issue your own certs, so that they can be just-in-time registered in any account that you're in any region your device connects to. And they're also eligible to be migrated via cloud-side logic between regions. So any region that this device connects to with its same stable cryptographic identity, it can be registered and ready for use in that region. And that's really nice. Devices can also be registered and claimed in multiple regions to support failover. So this can be abstracted from the application, but depending on how you want your resiliency to work, how you want fast failover to work, and what kind of pattern are you doing, an active-active pattern or an active-passive pattern for multi-region replication, the claim calls can be issued to any region in which this device has been registered. And then it can be active for the application, and to the end user, the application just works. Another thing we can do is we can use AWS IoT Jobs to instruct a device to update its configuration and cut over to a new region. And again, this kind of satisfies our core requirement of physically interacting with the devices as minimally as possible. When we need to update anything, we can do that from the cloud without interacting with the device. And so the device receives a job that's telling it to cut over to a new region. All it needs to do is update its MQTT broker endpoint to the one that the job tells it to switch to, and we're off to the races. Because we're using our certificates that were issued by our registered CAs, which are registered in both of these active regions, the device registers just as we expect. No need to re-roll new keys and certs, and off we go. So a couple limitations and challenges as we've been doing this that I want to talk about. That way they can be in your consideration as you're designing your applications. Firstly, the just-in-time multi-region registration pattern does require the device to connect first to each region in order to register. And what I mean by this is the device sort of has to be the initiator. Each region in which we're operating is ready for the device to connect, but in order for it to actually be in use, it has to kind of make that initial connection to each of the regions in which it's going to connect. And that's as opposed to potentially using cloud-side replication logic in which you connect to one region and then your cloud automatically replicates that state between regions. But there is a sort of kind of simplicity and elegance to using just-in-time registration that is less error-prone maybe than having cloud-side replication logic if you can handle having that device be the initiator for any region it's going to operate in. Secondly, using IoT jobs for region switching events does require a little bit of tricky choreography, and you might be able to kind of imagine how this works. If I issue a job to a device telling it to cut over to a new region, well, that job that job exists in the source region, and I necessarily can't have my device mark it completed before switching regions because it hasn't done it yet. But as soon as the device does cut over to the new region, it can't easily report that job complete in the source region. And so a good solution to this is to have an MQTT topic in the destination region, which your device will publish to, and then in that destination region, a message will be forwarded completing that job in the source region to kind of complete the circle. But as you can see, that's a little bit of kind of a complex choreography, and so you have to take that into consideration when you're issuing jobs that are going to command the device to move between regions. Thirdly, to leverage that dynamic bootstrapping pattern that Wally was talking about earlier, you do have to support HTTP on your device. And so if you have a device that supports MQTT only, and adding HTTP is not an option, the best solution is to have kind of a home base region where your device will first connect, and that home base region over MQTT will immediately kind of funnel your device, perhaps based on some of those identifying attributes that you put in your certificate when you issued it, into the region in which it should operate. But that's just a consideration, that for the HTTP-based dynamic bootstrapping, now you have to support another library on the device. Another interesting challenge is devices that connect through a gateway and not directly to AWS IoT via certificate can't take advantage of this just-in-time registration pattern that I've been talking about. And this is particularly applicable to topologies like our Argus M application, where we have a gateway device that connects to AWS IoT, but our edge nodes, the low-powered mesh networked edge nodes that I described, are not connected directly to IoT Core via certificate. The gateway is talking to AWS IoT on their behalf. And so in that case, those devices can't take advantage of just-in-time registration because they don't directly connect. And so cloud-side replication logic for any state you have for those edge node type devices in the cloud has to be used to make sure that state's replicated appropriately. And then lastly, we, and perhaps you, keep extended attributes for devices in your IoT applications in places other than the thing registry. And when that is the case, we have attributes that are stored in DynamoDB tables, for example, and those need to be accounted for when you're talking about replicating between regions and doing fast failover and all of those things, making sure that state remains in sync. And of course, there's many ways to do this. This is kind of touching up toward that application layer that Wally was talking about, where you could use global tables or other active replication between those things. But in any case, it needs to be considered. So summing all this up, first of all, managing and registering your own CA with AWS IoT in multiple regions and taking advantage of just-in-time registration is a great way to kind of instantly get a lot of multi-region flexibility. Your certs are now, without reissuing any certs, they're eligible to be used in multiple regions with several of these patterns. And that's given us great flexibility in our application. Separating device registration, the initial provisioning and connection to IoT Core, from the association with an owner and application via claiming also gives you multi-region flexibility. You kind of simplify the problem into two simpler chunks that can be handled individually, which reduces the complexity of your multi-region configuration and is less error-prone and is a nice pattern for supporting these types of topologies. IoT jobs, these are great to leverage to instruct devices to migrate between regions or update any other configurations, including failover, and particularly for us when we have applications such as Argus M installed in harsh industrial environments. We don't want to touch the devices physically. We don't want to be making field trips out to the installations. And so using IoT jobs to instruct devices to update configuration is a very good thing to do. And then lastly, all of this that we're talking about, deploying these IoT applications on a global scale, across multi-regions, this is a huge challenge that would have been hard to think about, not that many years ago. But building on IoT, AWS IoT makes deploying applications like our Argus M product at this kind of scale across multiple regions with resiliency, and it makes it possible. And that's really exciting for me and my team. So now I want to hand it back to Wally, and he's going to dive a little bit deeper into several of these multi-region patterns. Thank you.
Thank you so much. Thanks, Lucas, for that. As a funny aside as well, Lucas and I met last year randomly at a Chalk Talk, and it was just like, oh, we introduced each other, and then he's like, oh, I'm speaking with this guy, Wally, and he looks down, and he's like, I have his business card from last year. So things come full circle. So we've done a lot about, like, what are the table stakes of multi-region, what are the things you should be using, and how does this kind of look? What I want to do now is actually dive into, okay, what are the architectures, what kind of things you need to replicate, and what events do you need to pass back and forth? To really lay that off, you've got two considerations for going multi-region. You have an active-passive strategy. If you're really doing it for like DR scenarios, resiliency, you want to cut from one region to another, you'll take the active-passive route. If you're doing it primarily because you want to essentially run your devices in any region within the deployment, I want to run it in US East 1 or US East 2, you're going to do active-active. And these two columns bullets basically list the steps it takes to do active-active or active-passive. The plus side is when I get into these architectures, both of these steps require you to do two things up front. You have to replicate everything in your registry. So all of your attributes in your registry, you need to put from one place to another, one region to another. And then, as Lucas mentioned, we have to replicate the certificate information as well, again, through some CA that you already provide. So we start with active-passive. Again, primarily, if you're looking at this, you're doing disaster recovery. You need a primary and a standby. And when you do the cutover, something unique in active-passive is that the data, when a device connects to that region, it should be pinned to that region. Meaning that any processing that happens, whether I go from US East 1 to US East 2, all of my processing happens in the region I'm connected to. And this is kind of the behaviors of active-passive. So again, we've got to do these 5 things. And so I'm going to spend the next few minutes going over what all these look like. So you can figure out, okay, if I do registry replication, what does that look like? So with registry replication, the things you have to think about is you need to essentially register everything that happens within your registry or impacts your registry. Whether that means that jobs are going to do things like update the things or thing types or the policies or the groups associated with a device, anything that happens with the registry you have to replicate. There was this little known launch that happened last year. We did device management and it was like, great, you can do OTA updates and jobs. I got really excited about the fact that with device management, we released this thing called registry events. And think about registry events as almost like a tail log of your registry. Whenever you make a change in your registry, if you turn on registry events, we'll publish a message to a set of topics for you. And these topics are grouped. You have your thing events, so anything that happens to a thing, if it's created, updated, deleted. Anything that happens to a thing type, not just when a thing type is created, but when a thing type is associated to a thing. Similarly with thing groups, when you create a group and you put a bunch of devices in them, it'll say, okay, here's a create event for the group, and here's an add event to the group. Again, all of this gets published to you on these set of topics so you enable them. And what's nice about these registry events when you think about doing multi-region is you kind of start grouping them into the values that you need to send to the other regions, and those are your operations. In this example with the thing event, everything in green is kind of my operation. I've got a thing event. It's a updated, so operation is updated. What is it? It's a thing name. What type does it have? All of this information lets me essentially run the same API in the other region. And then for going multi-region, we need some unique identifier. We need a way of basically saying, okay, have we processed this event yet in the region it was generated in? And again, with these registry events, we create a unique event ID every single time an event is processed. So what does it mean for our multi-region replication? We need to replicate our registry from one place to another. So in this case, our users, our administrators are going to be operating against, let's say, the control plane of AWS IoT. Every single time they make a change against AWS IoT, we're going to trigger a step functions workflow. We trigger step functions because what we want to do is we want to do a bunch of sanity checks. So if I'm doing active passive, I need to go, is this my active region, or do I need to send it to my passive region? If you're doing something like active active, you're basically saying, well, have I seen this event before? Does the other region need to know about it? So in our step functions, our first step is just to figure out routing. Where does this event need to be sent to, if anywhere? And then if I do need to route it somewhere, my step functions basically sends it to another Lambda, and that Lambda's job is to persist that event. We persist that event in global tables. So we're using DynamoDB global tables. This allows us to have all of our data synced from one region to another. Once we've synced it to that region, in that other region, we've enabled DynamoDB streams on that global table. And we listen to that stream as events come in, and we basically say, since this is every single event that's ever happened, when you come in, I'm going to parse you, look at what kind of registry event you are, and I'm going to run the ancillary, kind of complementary AWS IoT API directly against AWS IoT Core. And with just these simple steps, we're able to essentially replicate from one region to another all of our registry information. I mentioned before, we always want to think about how we add resiliency and redundancy to our applications. And I also mentioned that you can do a one account with all your deployments, or you can do an account for a single region. So you have that kind of deployment flexibility. Some considerations to think about, again, with single region resiliency is you need to be able to have some backup and failover in this. So if for some reason you can't write to DynamoDB, for some reason you can't get across the wire, you should have a failback strategy. What I actually recommend is we have an open source library for Kinesis streams, cross-region replication. The exact same workflow that you do for DynamoDB, you can actually use with that Kinesis cross-region library. So again, giving you some resiliency within the region and planning up front. For some reason I can't get to Dynamo, I still need to replicate this, so I'm going to fall back to Kinesis. The second part of this that we've talked about over and over again is bringing your own CA, and that really is using just-in-time registration. So as Lucas alluded to, when you do just-in-time registration, it publishes a registered event on a specific topic. So it publishes on AWS/events, certificates registered, and then the CA certificate ID. And then you get this metadata about the certificate itself. When you use that information, you can apply a pretty similar pattern for all of your certificate information. Now your devices go connect to AWS IoT Core. That registration rule that gets published by just-in-time registration, you kick off another step functions workflow. Again, I like step functions here because when you're using just-in-time registration, you have to make a lot of API calls against AWS IoT. You've got to say, got to create a thing, and got to create a policy. I got to attach a policy to a thing, and a thing to assert. There's a lot of gymnastics. So step functions gives me some nice retry logic as it essentially creates the device and creates the identity for it. Then I persist a new identity out into that same global table. I use one global table for all this replication because it's essentially my event store for everything happening in a registry. It gets replicated across. Something slightly different, you can use just-in-time registration across all the regions, as Lucas mentioned. But when I get into my demo a little bit later, since you have the certificate information, you can just do bring your own certificate through the control side in that target region, and your device is already basically there. So instead of having the device go connect to each one, you can say connect to one, and I will persist your certificate everywhere for you. Of course, this goes against AWS IoT Core. And one note that I put down here at the very bottom with the green is if you end up using this pattern, there is a little known additional flag you have to set if you use the same subject name in your certificate authority. If you use the same subject name in your certificate authority, you have to pass the CA back to us. So if you plan on using that pattern, you just need to keep another map of what's my CA associated. So I can go and pull it and essentially apply it with that bring your own certificate. If you don't use the same subject name, you can just take this device and just say register. So I mentioned the just-in-time registration event kind of gives you this base information, a certificate ID, CA certificate ID, timestamp, and all of the kind of ancillary fields. Unfortunately, you can't take that immediately and just send it to the other region. And the reasons why is that things like the certificate ID and the CA certificate are associated to the region you're in. So what we end up doing is we basically take that identity, and as we go through step functions, we create two unique events. We basically say, well, we've got a just-in-time registration event, but what I really need is a certificate event and a policy event. And what the policy and certificate event look like is they basically look like registry events. This is why I can send them to the exact same data store. And in this case, what we do is for the policy event, we basically say, well, I have a policy. Is it created, updated, or deleted? And what kind of status do I need to give to this policy? Am I attaching it to a certificate or not? Am I detaching it from a certificate? And the same thing happens with a certificate event. What do I need to do with the certificate? And more importantly, since I want to register it programmatically, I also then pass in, where is it? Somewhere down here, the certificate PEM file. So I basically say, well, I have the CA, and now I have your certificate file. If I send you to the other region, I can now register you. So this all gets aggregated and then sent across the other region. Once you get those first two steps out of the way, those are big steps, but they're doable steps. Once you get them out of the way, the rest of active-passive is actually really easy. It's exactly what you do for your traditional applications. You have a pilot-light infrastructure running in your standby region. In this case, it's US East 2. If my device cuts over, I then say, you are now pinned to that region. You can't go to another region. All of your data goes here. We process it here. So it now becomes my primary. And then now that my device is actually running here, I essentially just start adding more infrastructure so that as more devices move, I can handle the replication. But again, this is the easier part. You essentially issue to the device, go to the other region, and everything's already set up for it to run. And when you're doing that active-passive scenario, your cutover strategy is also easy. It's the same two things we talked about. You can either bootstrap and just say, we want you to cut over. We're going to update our bootstrapping endpoint. And when you come back to it, you come back every hour, every day, you'll naturally go to the other endpoint. Or you can issue an OTA. So if your device is connected to AWS IoT Core, you can just say, I just need to go to the other region. But it's all cloud-driven. We don't need to have additional kind of device-side logic to do what really is like an active-active kind of going between endpoints. So what I'm going to do is I'm going to switch to my laptop, and I'm actually going to show doing the cross-region replication, just-in-time registration, and all the crazy stuff that we just saw. And hopefully the demo gods are on my side. Cool. Let's see. Perfect. There are many screens running, so I would try to make as much sense of everything happening at the same time. So if you're looking at this kind of front screen that has more devices in them, I'll kind of make it a little bit bigger. That's our US East. So this is where our devices are in US East. And on this other side here, this is all of US West. So you can't really tell the difference between Chrome and Firefox, but one is Chrome and one is Firefox. So what I want to do is I'm going to be in North Virginia, and I've actually already configured a bunch of rules for AWS IoT. So I mentioned you need those rules in place to listen to registry events. And if you can see in the middle of my screen, I essentially am saying select star all of my registry events. And then I look for specific ones. I don't replicate all of them. Some of them are a little bit redundant. So I say look for things, thing groups, thing types, and any of the associations that come up in the registry related to things, groups, and types. And then what do? I trigger my step functions workflow. And of course, since I said the best practice, you need to have resiliency and redundancy. My error action is SQS. So for some reason, I can't process step functions immediately. What I do is I fail back to SQS, and then I read off of SQS periodically and just execute the step function workflow myself. So again, I'm just having a way that for some reason, if I can't actually get out the door immediately, I haven't lost my replication information. Cool. So what I'll do now is I'm going to essentially just like do what you might do in a console. I'm going to create a thing, create a type, I'm going to create a group, and I'm going to associate all of them. And I'm going to do this in North Virginia. And then as I do that, the registry events are going to kick in, and they're going to start sending that to US West. So all this is happening. My step functions is going to kick off. I'll start creating it, and I'll show you the step function so you see what's happening. And then we'll go to US West. Hopefully everything's there. But it should be there, and then we'll talk a little bit more. So I'll create a single thing. I'll call it multi-region fun. I won't give it a type just yet, so I'll just create the thing by itself just so we can kind of see it created, essentially do everything separately. So my reinvent multi-region fun is listed here. What I'll do now is I'll create a new type as well. So let me create a multi-region one time. And I'll create that as a type. So again, I'm now just doing a bunch of creates. I'll also say I've got to group these for a deployment, so I'm going to create a group that's just deployment and create thing group. So I've created all three of these things. And so now what I've done is I've just switched tabs over. This is my US West, so you can see there's less things in it already. So now you can know you're actually in US West, because I had 6 in one and 3 in the other. Actually, did it stay in US West? There we go. Oh no, this is my US West. This is my US West. There's still 3 things. So if I, in US West, basically refresh, I have my 3 things. Now I have my reinvent multi-region. It's been replicated, multi-region fun from one place to another. If I go into my thing groups as well, I now have a new one, deployment. I now take it from one region to another. And my thing types, so my multi-region one time. And again, I continue to iterate on this because what's happening is step functions is sending it from one region to another. So if I go back to east, where I should be in this browser, I can do things like, let's say, let's associate a type to this. So my multi-region one time, let's associate a type to it. And what's interesting enough, I'll go into step functions in a little bit, but this actually happens fairly quickly. Even going cross-region, after a few seconds, maybe like 5, 10 seconds, it's already replicated in Dynamo, through DynamoDB's DB streams, pulled off, API called, and replicated. In some cases, it happened so quickly that the demo kind of looked weird. I was like, oh, I went back, and it's like, oh, it's already here. It's like I missed it. So I'll show some things I did in step function just to show it, but just to know that it's like a very, very fast process. So if I refresh my browser again, what we'll see is that device I just created now has its type updated. So even these associations are being replicated across region. What I'll quickly do to add on to this, and just to show you that you can do this for just-in-time registration as well, is I have several devices that have been signed by a CA. And I'm just going to run both of them right now. And so if I'm back in North Virginia, what's happening is that these devices are going to start coming online, and they're going to go through some step function workflows. So to show you what step functions does in both of these cases, is I have one step function workflow that did all of my registry information. So if I go into it, into the definitions, what you'll kind of see is that I just had that very, very simple routing logic. And then behind that routing logic, it basically said, do I persist this or not? And in this case, I basically just checked if I've seen it before, and if I have, I then just say, don't persist it. If I haven't seen it, I say persist it. In the case of just-in-time registration, what these devices are doing, they're coming up line, and the first time they connect, they don't have permissions yet. But what I do in my registration flow is I basically create, let me see if I can make this a little bit bigger. I basically create this step functions walk down. I basically say, first thing to do, parse the certificate. Pull out the certificate information, like the serial number, like the validity date, so I can store it later. After I do that, I say activate the certificate. After that, I say attach the policy, create the thing, and then eventually I do 2 last things. One is that I wait, because this demo happened so quickly that I had to put in a buffer, so you can actually see the changes happen. And then I replicate that certificate. I send those 2 events out into DynamoDB to the other region. So what you'll see is I've got 2 devices running, and if I scroll up a little bit, what has kind of happened is they failed and disconnected just a few times because they're trying to register their certificate. They haven't actually been seen yet. But now if I go back into my regions, what I'll see is I'm going to have a brand new device with all of its configuration information in North Virginia. So if I go here, I've got these 2 devices. They actually use a serial number. That's why they're just long numbers. And these 2 devices have been bootstrapped. So here's my certificate. This is a certificate that was from the CA, my device certificate that was signed by the CA. And I've given it a default policy. And again, that same flow gets replicated into the other region. So I might have to go back. But if I go into my certificate information, these are my brand new certificates. Again, these are the ones that have been signed by me. They've got I used to live in Massachusetts, so I have my Massachusetts information in it. and again, the global policy. So just by a few, essentially, step functions, oh, wait, did I do that right? No, let me see, one time. Awesome. Just by using a few step functions in Lambda, I'm able to just start this replication process. And then if you notice, the rest of it is actually really, really easy. So we talked about active-passive for multi-region. What about active-active? What if I want to run so a device can connect to any region in a deployment and then still be able to operate? I would like to share a quote before we dive into active-active. I'm lucky to have a professor, Brian Kernighan, who, if you've had his C book, you probably know him. But he'd say, if you build something so complex the first time, it's going to be impossible to debug it. So when we think about active-active, what we really need to focus on is simplicity. When I show these next few architectures, we try to make them as straightforward in the logic so that the edge cases kind of fall to the wayside. So why would you want to do active-active? Seamless disaster recovery. So again, as devices disconnect and reconnect, that discovery endpoint can go to any device, any region in that deployment. It doesn't have to go, okay, here's my primary, I'll wait for you to send me to secondary. It just says, I'm just going to client-side load balance. If I see an issue, I'm going to cut across. It also means that both of your regions are hot. Anything running in those two regions, essentially are being utilized, versus active-passive, where you still need some pilot light infrastructure. There's also some additional cost benefits as well. Luckily, since it's active-active, the first two things are done for us, and we only need to focus on the last three, because for active-active and active-passive, you have to do a registry and a certificate information. The dual infrastructure, that's actually pretty easy. Whatever you run in your first region, you run in your second region. For your device information, you kind of put these in two aspects. Since your device is now pinned to a region, it's responsible for replicating its state to the other region. So if my device starts in US East 1 and it goes to US East 2, its job is to say, well, I have my shadow, I have my current state. I need to go replicate that first when I go connect to the other region. That's my job. But now I don't have to worry about, well, where's my current state? Well, your device owns it, and it tells you where to go. So if it needs to go from East 1 to East 2, it replicates its shadow from East 1 to East 2. So as you see, the shadow just magically appears. The other interesting thing, and where it kind of gets complicated, but you want to make it as seamless as possible, is where do you process your data? And if you decide to do active-active, you want to process your data once. So what does that mean? If I cut over from US East 2 to US East 1, I need to decide where am I going to process anything that's critical or time-sensitive. Any critical or time-sensitive data should basically be processed in the region the device is connected to. You can't wait to forward it back to the other region just because your application is there, like your user front-end application or internal application is there. You need to actually do the process wherever it's connected. What about things like telemetry, though? In the case of things like telemetry, you might have other consumers. You might have a mobile application, and that mobile application might be pinned to another region. It may not be in the same place as a device. In those cases, you have to route your logic from one region to another. You basically say, for this telemetry, it may not have to be processed here. I need to look up this device, this telemetry, based on the application, and decide, do I process it in a region or do I forward it along? So what might this look like? Let's say I publish on a data topic. This is my telemetry topic, and I've got an application 1 in it. When it comes up to AWS IoT Core, I can actually make use of substitution templates to say, look at the application ID, and based on the application ID, I want you to go to a specific downstream AWS service. Or I can make use of Lambda again. I can just say, well, I don't really want to parse the topic. I want Lambda to figure it out. So I'm going to send it to Lambda. It looks at the telemetry, parses out the app ID, and tells where to go. But the benefit with both of these strategies and having the app ID inside of your MQTT topic is you can then automatically route it to distinct downstream services. And if you, it's a little bit harder to see, but if you can see the naming convention, these are all Kinesis. I basically have named them in a sense after the region they're supposed to be associated with. So I've got a Kinesis stream that says send this to US East 1, another one that says this is the one destined to US East 2, and so on and so forth. So to give you an idea of what this will look like with the substitution templates, I have my Kinesis action. I say, here's a case. The app ID is that second topic, so I've got topic 2. And then I've got a case statement that says, if it's app 1, send it to East 1 Kinesis stream, app 2, East 2, and so on and so forth. Similar for Lambda. So Lambda Logic is more kind of pseudocode. I basically will take the topic ID and essentially assign it a nice name, like application ID. And then in my pseudocode, I basically parse it out, go to a routing service, and then route that event. The nice thing with active-active, if you go this route, again, there's lots of moving parts where you try to make it as simple as possible. You get additional benefits of how you decide to actually cut over from one place to another. You can still do the cloud-side approach. You can basically say, I want my cloud to dictate where you go. Also, as I mentioned before, you can do a device-side approach. In your bootstrapping, list all the endpoints, basically say you can go to any of these endpoints you want and let the device decide where to go. And all your routing logic is dictated by, is it critical, I need to process it wherever it is, or is it something that needs to be routed to another region? So just some considerations and trade-offs to think about. Active-passive, this is easier to implement. It's all about just replicating your data and essentially having a standby. Your shadow is really going to be sticky to the region, so whatever region your device, even if it went away for a little bit but comes back, whatever region is active or hot, that's where your shadow should be. Differently with active-active, it is more complicated to deal with. Try to make it as simple as possible. You still have to replicate your device information and certificate information, but also realize your device has to help in this process. So your device needs to replicate the data between one region and another in the case of things like shadow. So I know we covered a lot in an hour. Lots of things to think about, lots of demos, lots of really great use cases. Hopefully you can take some things away around the table stakes and being active-active and active-passive. So thank you so much. Enjoy the rest of reInvent. We'd love to get your feedback, so definitely complete the survey, and we'll be standing by for any questions. Thank you.